Hello, dear students. In this video, we are going to see some more examples in Lex programming. So, in the previous video, we saw introduction about Lex programming and we saw one example. So, in this video, I'm going to explain three more examples in Lex program so that you will be very clear about how to write a Lex program. The purpose of Lex program, as I have already explained, it will help to do the tokenization. It is a tool used in the lexical analyzer, which is the first phase of the compiler. So let's go into the program. The first example is here in this program, we have to count all the words starting with A. Okay, so we have to count all the letters. For example, if a letter is starting with apple or and or A itself. So I want to count all the words which is starting with A. So this is the objective of this program. So as you know that what is the structure of a Lex program? You know, first part is declaration as we discussed in the previous video. First declaration, followed by have to put double percentage. Followed by that you have transition rules. So the format of transition rules is you have to write the pattern followed by the action to be taken. Then you have 2%. Then you have auxiliary functions. So this is how you write a Lex program. So this is the syntax to write or the format in which you can write the Lex program. So look at here in this example, as we want to count the words starting with A. So first I have to count here only one thing, right? So I have only one variable as we have discussed. See if it is a C program, then you have to start with percentage open curly brace, percentage close curly brace. So this is just a variable declaration to count all the words starting with A. Now followed by, I'm doing some other declarations. I'm saying A to Z, small letters, capital A to Z. All these are named as alpha. You can give any name, but this is the pattern. Similarly, I'm going to say 0 to 9. I have given the name as digit. So these are all declaration. So if I say digit, it means it is 0 to 9. If I say alpha, it is like any alphabet. And then I'm saying space means tab space or a single space or a slash in. So these are all considered to be space. So if I say space, it means all this. And then I say start. Start means here in this program, according to this program, I have to say starting with A. So I have say cat A. So which means start means it's see that whether it is starting with A. So I have declared all this four in addition to the C variable declaration, which is kept inside this percentage open curly brace and percentage close curly brace. So declaration part is over. And after declaration, you should have 2%. So 2% is given. Then what is the second part? Transition rules. So what is the structure of a transition rules? So the structure is first you have to write the pattern. Nearby, you have to write the action for it. So action can be mostly in the C program code. Okay. So here, just I'm saying start. What does mean by start? So if it is have A in the very beginning, for example, I'm saying an apple a day. So A, small a, okay. So because I'm said only small a's here. So here the sentence itself is starting with A. So that is what mentioned as cap A. So if it is starting in the very beginning, if it is having A, so this is identified with the cap A. So if it's so, then count, increment this count variable because we have to count those things. Otherwise, where are the other place A can have, A can come? So here is also A. So this A, previous to A, you have a space, right? So that's why I have given space. So what can be space? A space, a backslash T or backslash N. All these are considered to be a space. Followed by the space, you can have A, right? The A can be a small letter A or a capital A. That's what it is. So this pipe symbol represents this or this, any one of this. Followed by, I say alphabets. So alphabets means what? Anything from this, any other. See, followed by A, you can PPLE or any alphabet. So alphabets means we have already mentioned here. So I say alphabet followed by a digit also can be there. So alphabet, after A, you can have anything. That's what here. So after A, I can put 100 also. After A, I can put 18 also. I can put and also. So A should be there or capital A should be there. After that, you can have any alphabets or digits. So that can be coming 0 or more number of times. It can have or it may not have. So there is a star. Star means 0 or more number of times. So if this pattern is there, then increment the count. So we have completed the transition rules. Then followed by again put to double percentage. So here it is. Then as we discussed already in the previous video, we have to write the main function of C, and YYN is pointing to the input file. We represent it in C as F open file function, and the input is in the file sam.txt. I have read it in read mode. And YYLex is the entry point of the Lex program. And now here we have only one variable to be printed. So I have one printer function to print the count. And then that's it. And then we know what is YYWrap. So YYWrap represents the end of the file. So this is how we can write a Lex program to count all the things starting with A. So instead of A, it can be any letters. So if, for example, if I want to count everything starting with what I can say Y. So what will I do? Instead of A, I'll say Y here. And instead of this place, I can say small y or capital Y. Like this, you can do it. That's it. Now let us discuss the next program. So here is the next Lex program wherein I have to count the vowels. So you know what is a vowel, right? A, E, I, O, U. These are the vowels. So I want to count the vowels in my input. So for that we are writing. So here again we have to count only one thing. So I have a C code. First part is declaration part, right? So percentage open curly brace. I have declare only the count variable and close it. Percentage open curly. So I don't have any other declaration here. So that's it. And then double percentage. And now I have to say the translation rule. What is translation rule? I have to say the pattern followed by the action. So how will you find the vowels? So as I told you, vowels A, I, U, but it can be a small letter or it can be an uppercase, capital letters. So I have written both. So if I write something inside the square bracket, anything out of it. Okay, it says the all options, any one out of it. So if I find any one of this in my input, what I have to do? I'm going, so action. So what is the format of a translation rule? I have written pattern followed by inside the curly braces, you have to write the action. So if I found such thing, I'm going to increment the count. And here we have given the statement echo. You can skip it. What is the meaning of echo? Is immediately printing that particular character. So that is echo. So that's it. This is the only thing we have to do here. Only action to be done here. So that's it. And immediately have to put 2% symbol after transition rules. So finally, we have a main function wherein YYIN variable point to the file where we have the input. As usual in C program, fopen is a function, help us to open a file and the file name and in the read. And YYLex is the entry point of the Lex program. And here I have to print only the count. So I use printf to print the count variable. And then I have a YYWrap to denote the end of the file. Hope you got it. And now the last program I want to explain here is, I want to check whether a given number is an even number or not. Okay. So here I want certain libraries. So first part is declaration. So I'm going to use these two libraries from the C program, and also I'm declaring a variable I. And then followed by 2%. So here, what is the pattern to be matched? So the pattern to be matched is, you have a number, get any number. Okay, so in the previous examples, I said 0 to 9 can be given a name as digit or something like that. Here, I'm not going to give any name. Directly, I have used 0 to 9. This is also correct. So this, if you have 0 to 9, one or more number of time, what you have to do is, I'm going to write the C program for it. I'm going to use a variable, which is, see here, I. What is, so I is already declared, but I have not assigned a value. Here I'm going to do I equal to YY text. So if you remember in the previous video, I have explained what is YY text. It will be pointing to the lexeme. So what lexeme it will find? If it is finding any number. So that number will be present in YY text. So, okay. So to the input characters, the matched pattern, the lexeme, that will be present in YY text. So that is converted to integer. What is A to I? It is a function in programming C program which convert the ASCII value to integer. Here, everything is read as a ASCII value. So even though I write it as 56, it is read as a character. So I have to convert this ASCII value. It is read as a character. So I have to convert this to an integer. So I am using this function. So now I has the particular number, which is found out by this pattern. Now I'm going to write the next statement. See, I have used a semicolon. So one statement is over. The next statement is I'm checking this is all C code. So I'm checking if that particular number, mod 2, is going to 0 means, it is an even number. So I'm print here itself, I'm doing all the actions. Because, nearby, we have already written in the transition rule. The transition rule can have pattern. Nearby, you can write the action. The action can be a C program, right? So that's why here. So here itself, I'm printing print even. And then if it is not so, then definitely it's an odd number. Because you are getting only the numbers here. Check it. This is the pattern we have written and this is the action. So everything is done here itself. Now in the main function, just we call the entry point of the Lex program, that is YYLex. Because all the options, all other operations are already completed here itself. Right? So hope you can, from this 3 Lex program, hope you can understand how you can write the Lex program in different scenarios. So please go through it once again if you have any doubt. Thank you, Ma. God bless you.